All right, this shouldn't take too long today, I hope. So what we're going to do is start with an example. I'm not even going to teach anything just yet. This is going to lead you up to another formula. What are the two formulas we've learned so far if you want to graph something? Yeah, we had the standard form and we had the slope-intercept form. With the standard form, you can find the x and y intercepts, right? With the standard form, you can plug the stuff in, set x equal to 0, y equal to 0, plug it back in, plot a couple points, boom, you got a line. Good. And the slope-intercept form, you've already got the y-intercept right there. You find the slope, rise over run. You got 2 points, boom, you got a line. All right? So this is, it's kind of like the slope-intercept form, but it's not the intercept. It's got the slope part of it, but it doesn't necessarily have an intercept, okay? It could be any point at all. All right, let's do this first example before I run out of time. It says, write an equation in slope-intercept form for each line described. So here, I'm going to describe a couple things. So I tell you the slope is -3/4, and I tell you the y-intercept. Wow, that's pretty easy. So I tell you the y-intercept, which is 7. All right, so pretty easy. So what is, it says, write this in slope-intercept form. Okay, that's what the equation tells you to do. Slope-intercept form. All right, so what is slope-intercept form? It's what? Y equals mx plus b. All right, so what do? We just write y equals, what do we know here? Right, m, or the slope, is -3/4, and then you just write in a what? X, and then what is the y-intercept? That's a b, isn't it? So it's 7. So I just put +7, and bam, there you go. Super easy. All right, what if I did this? This is kind of leads you up a little bit more to what we're going to do. This time they tell you the slope again, but this time they tell you that they don't tell you a y-intercept. Okay, they tell you that it passes through. It passes through the point 1, 3, or 1, -3, sorry. It's not just any random point. That point actually lies on our line, all right, that I'm describing, that we're trying to describe here. So this point is on the line that we want to draw, or we want to write the equation of, and it has this particular slope right here. So how in the world do we do that? Well, actually, we are going to use that slope-intercept form again, but it's supposed to be an x, all right? But the thing is, I don't know the y-intercept. I do know the slope, so I could put that -6 in for this, correct? But I don't know the slope, so how in the world am I supposed to do that? Well, here's one thing about the x and the y. We didn't probably talk about it too much when we did this. I've talked about this in the past. But this x and this y represent a point. What kind of point does it represent? It represents a point on the line. Okay, that x and y, usually we just write a y and then an x, and we just throw in the number for the slope, we throw in the number for the y-intercept, but we never really talked about that x and y very much. That x and y represents any point that lies on the line. So if I drew my line and I knew a whole bunch of points, I could say, oh, that point, I don't know, making something up, -3, 2, that lies on the line, okay, or whatever. So do I know a point that lies on my line in this problem? Yeah, what is that point? No? 0, 7. This is part B. It's a completely different problem. 1, -3. 1, -3. Okay? So look, I do know a point on my line, right? So what would I call this? What would I call the 1? That's my x, and what's the -3? That's my y. Everybody see that? So if I know that that point lies through the line, or lies on the line, and it does because it says it passes through that point. So I can plug those in. So now I can go back, plug everything in. What's the one thing that I'm missing? I got the slope, got the x, got the y, so I can find the y-intercept now, can't I? All right, so let's do that. Now, if I was asked to graph this, I wouldn't have to make an equation out of it, but they want you to write it in slope-intercept form. They don't tell you really to graph it. Like if I told you to graph this, you could plot the point 1, -3, and then rise -6, run 1, and then you've got your graph. But they're asking you to write the slope-intercept form with this information. Everybody, does that make sense? All right, so here we go. Let's plug some stuff in. What is my y? -3 equals, what is my m? -6. And what is that m doing to that x? It's being multiplied. What is my x? It's a 1. And then plus b. So now I could solve for b. Let's do that. -3 equals -6 plus b. Add a 6 to both sides, so b is what? +3. But what do we want to do? That is, I don't just write b equals 3 and that's my answer. I want to write my equation in slope-intercept form. So what would my equation be then? Put it right here. Y equals -6x, and now I know my b plus 3. And there you go. So that information right there is this equation. If I would graph this equation, it would be the same exact line as if I just put a point at 1, -3, and then did the slope, the rise over the run. Okay, it'd be the same exact thing. Everybody with me on that? Let's do this real quick. I've got 7 minutes. I should be able to do this. With that said, we're going to come up with a new form of an equation. Instead of writing, let's see, what do I want to do here? Yeah, let's do this. Let's start with the definition of a slope. Rise over run, or the change in y. Charles, you with me? Change in y over change in x, correct? Hunter, you with me? Somebody whack him. That's not a whack. Whack him. Whack him in the head. There you go. Hunter, wake up. Or you're going to go sleep in Mr. Sarek's office. I'm serious. Get your head up right now and look up at the screen. That's the way you should be. Do you remember the change in y over change in x? Nope. So what I'm going to do, a lot of times we go y2 minus y1. I'm just going to go y minus y1. And what do you think the bottom's going to be? X minus x1. Now, watch what I'm going to do. I am going to get this by itself. So we're just taking the definition of the slope, and we're just going to get that by itself, and that basically, not basically, it's exactly the equation that we're looking for. It's the form of the equation of a line that we're looking for. So it's pretty basic. So let's get that by itself, so that means we have to get rid of this. How do I get rid of that denominator? Multiply it by both sides. So what do I get? I get y minus y1 equals m, what? Times, because I'm multiplying it by both sides, right? I'm multiplying this side by x minus 1. I'm multiplying this side by x minus 1. So there's my x minus 1, and that right there is the new form that we're looking for. So what does it have in here? Well, let's do this. Let's change colors. It has an x and a y, okay? That would be the ordered pair that they gave you. You know that problem where we just finished, that 1, -3? That would be your 1, that would be your -3, and that would be your -6. So instead of going through all that stuff that we did before where we had to put it into slope-intercept form and all that, and then graph it, we could just keep it in this form right here. So let's go back to that same problem. So do we have time for that? Yeah, we have time for that. So let's go back to that same problem. So what did I say the x and y was? 1, -3. All right, that was the point on the line. So this x1 and that y1 represent the point on the line. What is the slope of my line? On that problem we did earlier, it was -6, correct? So with that said, if I have a point, if they give you a point on the line and they give you the slope of the line, you could use this formula. So guess what we're going to call this form? The blank blank form. What do you think? Just wrote it down. The point slope form. And that's what we call it. Okay? We call it the point and dash slope form of an equation of a line. So this is it right here in that box. That's the point slope form. So it's kind of nice. When they just give you some point on the line, not necessarily the y-intercept, and they give you a slope, you can use this form and then come up with a nice equation. All right, so let's do it. What is it going to be? This y is just going to be y. This x is just going to be x. But this x1 and y1 are my point, okay? And this, or it is my point. This m, this slope, is going to be this slope right here, -6. So let's write it down. So it's y minus y1. What's my y1? It's -3, which is going to make this +3. Everybody see that? Okay, I'll just write this above here so you can see where we got that. So it's y minus -3 equals, what's that? -6 times what? X minus 1. So right there, that's the form. That's the point-slope form of the equation of a line that goes through this point, 1, -3, and has that slope of -6. Now, if you wanted to, you could take this and put it into slope-intercept form. How would you do that? Basically, you just solve for y, wouldn't you? So you just subtract a 3, do your algebra, make it look real nice, and you got your slope-intercept form. All right, so it's kind of nice. It's pretty helpful. It's pretty practical. This point-slope form is kind of nice. Now, you could always do this. You could put everything into the slope-intercept form, but then you'd have to do some math, solve for b, plug it back in. It's still good. Or you could just go straight to the point-slope form. Let's do the equation or the example that they give us here. I got like 2 minutes. So, oops. So let's do an example. I didn't even write down what example it was. I guess it's example 2. So they give you a slope, which is 1/4, and they give you a point, 3, -4, that lies on the line, okay? And they want you to write both, the point-slope form and the slope-intercept form. So let's do the point-slope first. Point-slope first. So what is it? It's y minus y1 equals m times x minus x1. And you just plug them in. So it's y minus -4, which is a +4, equals m, which is 1/4, times x minus 3. So right there, that's your slope or your point-slope form right there. You could just leave it like that, perfectly fine. We don't have time for this now, but you can try this on your own. You could change this into slope-intercept form, couldn't you? All right, so just subtract a 4, do the math, right, distribute the 1/4, and so on. So here's your little homework assignment. So it's section 1-4. It's page 30. You can do both. And you're going to do 11 to 22. It's only 12 problems. Okay? There it is. That's your homework. So you got a quiz on Monday, and you have this homework due on Monday.